In this video, we're looking into organic chemistry, and we are going to be talking about the 16 important homologous series in organic chemistry. So we'll be talking about the family, the functional group, and the general molecular formula. Please do well to watch this video to the end. Share this video to your classmates. Give us a like thumb and a nice comment. So now, let's start with the first one, alkane. But before I start with the first one, alkane, I will firstly give you the prefix of the first 10 members of an homologous series. So which is what? We have the first one as meth. After meth, we have eth. After this, we have pro. After pro, we have boots. After boots, we have pens. After pens, we have eggs. Then we have heps. We have non. Sorry, after heps, we have oct. Sorry about that. We have oct. After oct, we have non. Then we have dec. I believe most students will know about this because it's a very familiar thing that students used to know. It's a prefix of this. This meth means one, probably one carbon. Het, 2 carbon. Probe, 3. Boots, 4, 5, 6, 7, 8, 9, and 10. The number of carbon. So now let's start. Now looking at alkane. Alkane has a general formula of CnH2n plus 2. That's the general molecular formula for alkane, whereby the N stands for the number of carbon. Hope you understand. The number of carbon. That's what the N stands for. Meaning that the N is an integer, a positive integer. Maybe something from 1 to 1 million uncountable, you get. So it's a positive integer. And then the functional group is just that, is none. So alkane doesn't have any functional group. Although some people used to say, it has a functional group of dash, but I'll bet with you that it has no any functional group because all other members too used to have that bond, that single bond we have there. So just put none for that. Now let me explain better. Let me explain further for this alkane. This CnH2n plus 2, which is the general molecular formula for what? For alkane. Now, if the number of carbon is 2, so let's put 2 here. This will be what? C2, then 2 times 2 is what? 4, plus this 2, that is 6. So we have it as C2H6. So the name is going to be C2H6. Okay, something like, okay, now if you have this C2H6 here like this now, and then what about if the number of carbon is 3? Then that will be C3H what? 2 times 3 is 6, plus this 2, that's 8. That's C3H8. So that C2H6, that's what we call ethane. You can say that, look at this F, but we call it F. So ethane, that's ethane. That means, what did I add here to make it ethane? That is, I had the last 3 digits, the last 3 number there, letter rather. The last 3 letter in that alkane, that is ANE. So I had ANE to ethane, meaning that the suffix ending all alkane is what? Ane. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. That is, when the number of carbon is 1, we have it as what? Methane. That means this guy is going to be C1H4. C1H4. So the ethane is going to be what? C2H6. The propane is going to be C3H what? 8. C3H8, and so on like that. And that is the name. So just be adding ANE as the suffix. ANE to everything. Then it's going to give you the first 10 members of alkane. Now look at this very well. If you look at the difference between the if your number of carbon here is 1, then the hydrogen here is going to be what? 4. So we have it as CH4 bar. What of this H? That's going to be C2H6. Now, if you look at the difference between CH4 and C2H6, that is what? The difference is what? CH2. So that CH2 is, and look at the next one too, propane. Now, the difference between propane and ethane is also CH2. The difference between butane and propane is also what? CH2. The difference between pentane and butane is also CH2. So meaning that meaning that these members of this alkane, they differs with what? With CH2, or you call it 14 gram per mole, because if you look at the molecular formula for CH2, that is what? 14 gram per mole. So meaning that thing really defines what an homologous series is. So homologous series is a series of compounds in organic chemistry whereby each member differs from the next member by a constant unit of what? Of CH2, or 14 gram per mole, such as what I've explained here right now. So let's continue. So alkene has a general molecular formula of CnH2n. Look at it, CnH2n, meaning that the N still represents a positive integer. That means 1, 2, 3, 4, 5, 6, and so on. And then the H represents hydrogen, the C represents carbon. Now, what is the functional group for alkene? Functional group is a group of atom radicals or bond in an homologous series. So we they have similar chemical property, and then they give they allow us to identify what that compound is. So now the functional group for alkane is going to be C double bond C, just meaning that it has a what? A double bond. So if you insert 1 into this, if you replace this N by 1, whereby this is met, that means when the carbon atom is 1. So when the carbon atom here is 1, so this is going to be what? C1H2. C1H2. So C1H2 is not a compound in organic chemistry, because if you draw the structure, then the structure will not be possible. Do you get? So now, whatever if you put 2 there, that's going to be C2H4. C2H4 is 18. So add this one, propene, this guy butene, this guy pentene, this guy hexene, this guy heptene, this guy octene, nonene, and decene. That means I'm adding a suffix of ene, ene. That means the last 3 numbers we have there. So, and the functional group is double bond. All alkenes used to have double bond. And we have types of double bond. We have the conjugated one, the isolated one, and then the commutative one. So that one will be in our next video. So for alkyne is CnH2n minus 2. So the functional group is C triple bond C. So that's the functional group. Sorry, I'm writing this particular one for alkyne. Don't mind me. So that is C triple bond C. So that is what an alkyne is. So now, before that, there is what we call alkyl. Alkyl, ALKYL. Alkyl is represented as what? R, capital letter R, alkyl, which is the general molecular formula for alkyl is CnH2n plus 1. This alkyl simply means that when an organic compound, or probably an hydrocarbon, is lacking 1 hydrogen, you understand? When it is lacking 1 hydrogen, so that is alkyl. So and the alkyl is CnH2n plus what? Plus 1. So now look at the fourth family we'll be talking about is haloalkanes. Now this haloalkanes is, it is derived from the word halogens and alkane. Halogens and alkane. So it simply means that when you replace 1 hydrogen in that alkane, you replace it with what? Halogen. And we all know that all halogens, they are group 17 elements. That is the fluorine, chlorine, bromine, iodine, and what? Acetylene. Okay. So now this is going to be, instead of me writing this alkyl, you know that this alkyl I said is lacking 1 hydrogen, meaning that I remove 1 hydrogen. You can say this is CnH2n plus 1, and this alkane is CnH2n plus 2. So it's like as if I remove 1 hydrogen from this alkane, and that gives me alkyl. Alkyl, ALKYL. So, and this haloalkanes simply means that I removed 1 hydrogen from an alkane. I now replace that hydrogen by an halogen. So instead of me to now write CnH2n plus 1 here, then I'll just write R bonded with X. Now, what's the meaning of X? R simply means CnH2n plus 1. Take note. So what is the meaning of this X? This X is like as if is a symbol we use to represent an halogen in organic chemistry. So this X represents fluorine, bromine, chlorine, iodine, and acetylene. So now what's going to be the functional group for this guy the functional group is just going to be the bond X. Bond X. That's for halogen. That's for haloalkanes rather. Bond X. Meaning that it is the halogens that will bonded with an alkyl that will allow us to know that that particular compound is what? Is an haloalkanes. Haloalkanes. So let me give an example. If this guy is chlorine, for an instance, this guy is chlorine, and this is our alkyl. You know, this is our alkyl. You see the same thing here. When N is 1, this is going to be methyl. Hope you get. When N is 1, this is going to be methyl. When N is 2, this is going to be ethyl, because alkyl ended with YL. ALKYL. So this is going to be methyl, ethyl, propyl, butyl, pentyl. Pentyl is going to be C5H11. C5H11. So if I have here, if this R represents C5H11, then I added it with chlorine. That's going to be C5H11Cl. That will be what? That will be pentyl chloride. Pentyl chloride. That will be the name for this guy. Pentyl chloride. You understand? What about fluorine? If you add fluorine to this guy, it's going to be what? Pentyl fluoride. This is going to be what? C5H11F. C5H11L. C5H11F. So that is what? Pentyl fluoride. So this is the functional group bond X. Now the fifth one is alkanol. Alkanol. Alkanol means that the one hydrogen removed from an alkene, the one hydrogen removed from an alkane to give us an alkyl. You understand? So is replaced by hydroxyl group, which is what? OH. Replaced by what? Hydroxyl group, which is what? OH. Something like R bonded with OH. Remember that my R represents Cn, H2n plus 1. So the functional group here is going to be what? Bond OH. Bond OH. This bond OH can be written as this or like this. Bond O to H. Something like that. So now example. And then okay, you know, it's alkanol. Alkanol. So the suffix that will be ending the members of this alkanol is or. So the next one we'll be looking at is number 6. And that number 6 is alkane, also known as ether. Though I used to call it ether. Mind you, ether is different from ester. This one is ether, or you call it ether. Okay, this alkane, let me say, is the combination of oxygen. It has oxygen, you know, oxygen. It has oxygen in it. Now, how does it look like? The general formula is something like ROR. That's the general formula for alkane. So whereby the functional group is just bond OR. So that's the functional group, bond OR. So let's give an example. If this guy is methyl is CH3, right? And this guy is let's say ethyl. You understand? Let's say this guy is what? Ethyl. Ethyl is C2H5. So if you are now asked to name this guy, how will you name it? You will name it as ethyl methoxide. If you start from this guy first, this front one first, by saying ethyl methoxide, it's going to be ending with oxide because of the presence of oxygen. So take note of that. That is ether. The next one is alkana. That's number 7. Alkana. So the alkana, the general formula for alkana is RCHO. Mind you, our R means alkyl, and the functional group is just going to be bond CHO. So the functional group is what? Bond CHO. Okay, now look at this guy now. Alkana. Look at this guy. If our alkyl is methyl, that is CH3. So what are we going to call this guy? we will call it, CH3 added with another carbon here, making how many carbon? 2 carbons. You understand? So this is going to be what? Ethanal. Ethanal. We added methyl from this our alkyl as CH3. So combining with this carbon we have here, that's going to be what? Ethanal. That's ethanal. And if this guy is ethyl, so that is C2H5, combining with this CHO, that's going to be what? Propanal. You understand that? Now, how does the structure used to look like? Let me give you a sketch of how the structure used to look like. So look at this place. If this is R, then bonded with this carbon here, this oxygen is going to be like this, and this hydrogen will look like this. So this is how the structure used to be. So the oxygen used to have double bond. You understand? Carbon is tetravalent, so it has 4 valence electron, and then it must attach to 4 different things. Like it must bond with 4 different things based on its nature, the uniqueness nature of carbon. So bonded with alkyl, hydrogen, and 2 bonded with oxygen. So that is the functional group for what? For alkanal, bond CHO. Now looking at alkanone. Alkanone has the general formula of RCOR. RCOR, whereby the functional group is bond COR. So that's the functional group, bond COR. So example, okay, let me show you how the structure used to be. This first R is going to be a C double bond O, and then C double bond O. Here is going to be R like that. So what is the difference between alkana and alkanone? The difference is that this H, here is H and here is R. R simply means alkyl. So that's just the difference between the two. Alkana and what? Alkanone. So if you are, let's say, if this guy is CH3 here, and let's say this guy is CH3 too. So what is going to be the name for that? If we count the number of carbon we have here, that's 1. Combine it with this one, 2. Combine it with this one, that's 3. So that's going to be propanone. Propanone. You understand? Propanone. So that's okay. What about if this R here is C2H5 and this R here is CH3? So how many carbon do we have here? 2, 1, and 1. That's how many? That's 4. And that's going to be what? Butanone. Now take note. This alkana and the alkanone, the both of them, they are called carbonyl compound. Carbonyl compound. That is CARBONYL. Carbonyl compound. So that is that about the alkana and alkanone. Now let's go to the alkanoic acid, also known as what? Carboxylic acid. Also known as carboxylic acid. Now how the general formula looks like? That's going to be RCOOH. RCOOH. That means it has double O. And then what is the functional group for the carboxylic acid, or you call it alkanoic acid? That is an organic acid. You understand? It's a weak acid. So that's going to be bond COOH. So that's the functional group, bond COOH. So now, example, if this guy is methyl, that is CH3, you understand, added with ordinary carbon. So how many carbons do we have there? We have just 2 carbons all together like that. You understand? So that is going to be what? Ethanoic acid. 2 carbon like that. Look at this place. So we have ethanoic acid like that. And how does the structure used to look like? That would be R, C, double bond O, bonded with OH. Look at the way I draw the structure. R, C, double bond O, bonded with what? OH. So that is how ethanoic or alkanoic used to what? Look like. So what about if that R is what? If that R is butyl, that is C4H9 added with what? COOH. So that's going to be what? That's going to be pentanoic acid. Pentanoic acid. That's going to be pentanoic acid. So the functional group is bond COOH, and then this is how the structure used to look like. So your alkyl can be any one of these. Okay, so the next one is now, the number 10 is alkanoates. Alkanoates, also known as esters. Alkanoates, also known as what? Esters. So how does it look like? The general molecular formula for esters is going to be RCOOR. Now look at the difference between everything. You observe that for this alkanoic acid and this alkanoate, this one has H, while this have R. For this and this one, okay, for this guy and this guy, from this structure here, this one is H, this one is R. So therefore for this guy, this one is what? H here at this ending, why this one is R. But some people used to put prime on this R. You understand? On this R. And then the functional group is going to be bond COOR. So that's going to be bond COOR. Bond COOR. And that is the functional group for alkanoids, also known as what? Esters. Now, the structure is very simple. The structure just means that this H here, you will clean it and then change it to R. That's how the structure looks like. So change it to R. That's how the structure looks like. Now, let's give an example. If this guy here is methyl, that is CH3, and this guy here is what? Methyl as well, CH3. How will you name it? You will start from this guy here, this first guy here, by saying methyl. Look at me, methyl. After writing methyl, then you will now come here and say, you know that the carbon we have here is methyl 2 as well. That is 1 carbon. So plus this one, that is what? 2 carbons. So we now say methyl ethanoate. Methyl ethanoate. You will firstly name this alkyl we have here first, before you call the one from this guy from this place. So you will now end it with the suffix of oate. So that's going to be what? Methyl ethanoate. So that is an ester. So I'll be ending this video here. In my next video, that's going to be from number 11 to number 16. Please do well to share this video to your classmates. Give us a like thumb, give us a nice comment, and please subscribe to our membership platform. Give us a super thanks or super likes. At least it's going to motivate us, it's going to help me to grow. Please, thank you so much, and I wish you best of luck in any exam you are preparing to write. Bye. I love you.